going to be focusing on creating a very easy project for you to get your skills started with Fusion 360. In our program class, you've got a copy of the drawing that we're going to be working on. Uh, that particular drawing, I also made it available here. You can see that it is a very basic drawing of an L block. It's got some cutouts, it's got a hole. And so we're going to be creating this as a Fusion 360 model. We're not going to take it any farther than the model, only because the idea is basic success in a quick video. Alright, so let's get started. So let's flip this around. We'll turn this back off and we'll get started. So we're going to start by choosing a sketch, and when we choose the Create Sketch in Fusion 360, it's going to give us 3 planes to work on, and we have to choose one of the 3 planes in operation. You'll also notice the glint in the middle here, and it's got a red, a green, and a blue. Well, the blue is Z, the red is X, and the green is Y. So if we choose the red and green plane, it's going to be in the XY plane. So I'll also then look at the front, and if you come over to the right hand side, we've got the cube over here on the top. That cube allows us to select specific views that we're going to be working on. If we want to go back to the 3D view, we hit the home view, and that'll get us back to the 3-dimensional view. So it's really easy to get your view structure set up. So the advantage of working with Fusion 360 and other parametric modelers is that we just draw sketches. So we're just going to sketch out a shape, and that shape is that L shape that we originally saw. We're not going to worry about the size of that L, we're just going to create an L shape. And so when we're finished creating the L shape, you can see that we've created the shape here, and you'll notice that it's put these little icons. And these perpendicular icons indicate that these lines are all square. If I hit the undo here, and if I create a line that is not perpendicular, it's not going to allow me to put that icon on it. And so we can have a misdrawn shape, but we can always fix that. And so it's kind of good that we go back and repair that, because that's going to happen with you too, that you may not sketch it exactly 100% correct. And so this particular shape, as we know, it needs to become an L. And it says that this is parallel to this. This is perpendicular and parallel, but we've got an angled line here, so I'm going to need to make this perpendicular. So up across the top, you'll notice that I've got these constraints that I can use. I can do horizontal, vertical, coincident, which is points, tangent, which deals with circles, equal distance, parallel, and perpendicular. I can fix and unfix, which is basically locking, so something won't move or adjust. Midpoints, which is the midpoint of a line. Concentric, which is the center of a circle. Collinear, which aligns 2 lines up on the same plane. Symmetry, so that's like mirroring. And then curvature, which allows you to do a data point on a curve. So the idea is that we can do a perpendicular, and so I'll pick this line and I'll pick this line and make them perpendicular to each other. And since this was already locked into place, it cleaned up that particular line. The next step is that we have to add dimensions. So dimensions are easy. We've got a dimension tool here in Fusion, and we pick the line that we want to dimension. So this particular line says that it's 1.50. I'll click on it, and that line actually needs to be a total depth, or total height of 1.25. So we type it in and we hit enter, and it changes the height. This line here needs to be 2 inches long. Now this line here, that needs to be 0.5. And the same with this line, needs to be 0.5. And you'll notice that as we've drawn that, we've now basically constrained the shape and held it into position. Huh. So the next step is to make this a 3D model. So we've added 4 dimensions to hold this shape. And now when we look at it using the house view, I can see the 3-dimensional shape. I can finish the sketch and I can choose extrude. And what's cool about the extrude is that you can use the push-pull arrow here, or I can type in a distance, and the distance is going to be in the positive Z direction. Notice you've got the red line here for X, and you've got the blue line here for Z. So I can actually just grab this and we can drag this out. But in reality, we need to type in the exact distance. And so that exact distance is 1.0. Perfect. Now we've got a 3D model. Congratulations. The next step is that we need to draw a cutout here on this top surface. Well, we've got 2 options. Remember the process: sketch, constrain, develop the 3D model. So remember when we started with the sketch command. We then sketched out the shape, constrained it with dimensions, and then created the model. So again, what I'm going to do is I'll create a sketch on the surface that I want to work on. So I now have created the sketch. Notice that it's highlighted, that particular surface, and I'll look at the right-hand view. Now there's 2 ways that we can create this cutout. We're going to go the really simple, easy way. We're going to use the rectangle command. Now the rectangle command allows you to create 2 points. So I picked a point out here, and we're going to pick a point here. Opposite corners. We'll then add dimensions, and so the width of this particular object is 0.5. The depth of this object from here, from the top of the object to the depth of the cutout, is going to be, again, 0.5. But we have to make sure that this cutout is centered. So we're going to need to put a dimension in from the side to the side, and that needs to be 0.250. Boy, I was close on that sketch. And that pretty much guarantees it. Now what about this line? This line's still showing up as non-dimensioned. Does this really matter? No. The height of this above this plane, or that object, doesn't really matter. It's going to get cut out. So we're going to look at it again in an isometric view by picking the house. And you'll see that the cutout is dimensioned specifically. But now we're going to have to extrude it, but we're going to cut it out of the part. So we'll finish the sketch. We'll choose extrude. But this time, we're going to have to pick the profile. It wants to know what we want to cut. Well, we want to cut that surface. And we actually want to drag it. Notice that when we drag it through the object, it turns red to cut it out automatically. And you'll notice that the operation says cut. So the depth of the cut is up to you, and it's a negative number. So in this case, it has to be a minimum of a negative 0.5 because that's the depth of the original shape. So if I did 0.8, we're fine. We can choose OK. Congratulations. One of the cool things about this view cube is if I left mouse click and hold on one of the corners and I move my mouse, I can drag around and see the part. So I can real time change the view in a 3-dimensional environment. Alright, well we've got a couple of more things that we need to clean up on this part. The first one is that we need to drill a hole here in the middle. And then we've got to round off these edges too. But we'll do that at the very end. So the next step is creating a hole. And you'll notice that there's this tool called the hole tool. This hole tool is one of these features that allows you to create a hole on a surface. We're going to pick that surface, and we're going to drill a hole through this particular object. But before we get started, let's take a look at this hole command here. We're going to pick or select the face that we want to drill the hole in. The hole type is going to be a simple hole, It's not going to be counterbored or it's not going to be countersunk. Counterbored allows you to recess the head of a bolt. Countersunk allows you to recess or make the head of the screw flush with the surface. We're not going to tap the hole, meaning we're not going to provide a clearance hole so it's slightly larger than the actual hole size, or tap it with threads, or taper tap it with like a pipe thread, which is tapered, an NPT thread, which is a tapered thread. So you get a watertight, airtight seal with that taper. The drill point can be flat, like if you're going to use a reamer on the end after the drill, or you can use an angle, which is the standard drill. We're going to be drilling all the way through the part, so it makes no difference. So we're going to select the face. Now notice that where I picked the face, it automatically started to draw a hole. Well, this diameter of the hole needs to be a diameter of 0.5. So down here at the very bottom, let's go ahead and make this 0.50 so we get the actual hole size. You'll also notice that there's this dimension here. And that dimension of 0.544 is one that I'm going to need to dimension here, or position. Now I can add reference locations, and that's what we're going to have to do up here in the dialog box. So we're going to pick the reference edge, which was going to be this edge here, and that edge is going to make it a 0.50 offset. So it's going to make it exactly 0.50. From the front of the part, it's going to be 0.75 back. And so it moves it back to 0.75. And those are the two reference locations. We have to pick two reference positions to locate the object. We now have the depth of the hole, which right now is deeper than the actual object, which is fine. As long as it's deeper than the object, it's going to drill all the way through. We could say, instead of just drilling a distance or a depth, we can say we want to drill all the way through the part. And then we don't have to worry about the hole depth at all. When we choose OK, the hole gets created. We can left mouse click and hold the cube, and we can actually look down inside that hole. Pretty cool. So we have one more feature that we need to deal with, and that is the rounded front edges here. And those rounded front edges are actually 0.25 radius objects. And it doesn't show up on the print. Let me show you. So let me go ahead and turn on our canvas again. And we'll go to the front view and rotate it around. So you can see that we matched up the front view of the object with the front shape here, and that's really good to do. You should always create your 3D models based on the front view, because that's usually the most complex shape that you're going to create. You'll notice that there's no dimension here for these rounded edges, but from experience we can see that they're about halfway of that half-inch distance, so there'll be a 1/4 inch radius on those particular objects. So to make that work, we're going to use a tool called Fillet. And so right up here there's this little tool called Fillet. And when we pick Fillet, it's going to want us to select an edge. And so we actually want to pick this line. And that line is going to ask us, well, what radius do we want? And we'll type in 0.25, and it's going to pick that edge. And we can choose OK. We can also hit the plus sign and add another edge if we'd like to. Or we can choose OK and do the whole process over again on the other side. So I'm going to hit the plus sign and pick this edge too, and type in 0.25. And so now both edges are exactly the same. If we rotate the cube, that's the cool part about this, is that we can actually take and move the view while we're in the middle of a command. So we can see what's going on before we actually choose OK. So that actually looks just like this part up here on the top of the view. And we'll choose OK. And so realistically, congratulations, you have now created a 3-dimensional object. My suggestion is that you would want to save it. So to save your work, you can hit the File pull down, and you've got a couple of options. You've got Save and Save As. Since we haven't saved the file already, we're going to go ahead and hit Save, and we're going to call this demo for unit number 4. And I'm going to save it under a folder that I created for class instruction. You can create your own folders and manage your drawings appropriately. It's really important to create folders and put drawings inside folders. So when you're working on a project, all the drawings that you're working on go into the same folder and are just not located all over the place on your hard disk drive. So using this folder structure works really, really well. Now, if you actually wanted to take this and let's say, for example, you're working in the lab and you want to take it home, you'll need to export it. The only way to get the file out is to export it. So if you wanted to share it to somebody else, you could. There's a share tool, but there's also the ability to export it as a Fusion archive file. And once you do that, it'll give you a version number, and then you're able to save it to a location on your hard disk drive and work from there. I did fail to mention that when you hit the save button, you're actually saving it on the Autodesk server. So no matter what login you go to, that Autodesk server will have your files. It's when you go to the export is when it saves it to your hard disk drive. So it was an error in my part that I just mentioned about saving. Well, have a great day. I am so excited that we got our first model file created, and there's going to be many more in your future. Take care.